All right, we're going to do what I call a factoring review. I find a lot of people in Algebra 1 perhaps did not perfect factoring trinomials, something with three terms. So it's really because it's so important for the rest of math and Algebra 2 and beyond. We're going to go ahead and review right from the start. So if you feel like you didn't catch on to factoring before, we're going to start at the most elemental level and go through that. So we'll be factoring trinomials, something with three terms. And then we'll also talk about factoring difference of squares, which is very similar. Now, to understand factoring, I'll just do a quick refresher of what FOIL is. FOIL was the first, when you multiply x plus 3 times x plus 5, x times x would give you x squared. Then you do the outside, which is 5x. Then you'd multiply the inside, which is 3x. And then your last would be 15. So you'd end up with combining your common terms of 5x and 3x. So when you FOILed, you would get x squared plus 8x plus 15. What trinomial factoring is, it's starting with something and then working backwards to the form in parentheses. For example, it says to factor this x squared plus 8x plus 15, we know it's going to be in this form. Two sets of parentheses with an x and an x. Well, the reason we know it's an x and an x is because when we do the f of FOIL, x times x is x squared. We have to figure out what numbers to put in here and here. Well, it says, look at the last number in the function, x squared plus 8x plus 15. List all pairs of numbers that could be multiplied to give us 15. Well, we could have 1 times 15 or 3 times 5. Now, these are our two possibilities. Do any of these pairs add up to the coefficient of the second term? The coefficient being the number in front of the x, which is in this case 8. Well, 1 plus 15 is 16. That doesn't add up. But 3 plus 5 is equal to 8. Well, 3 times 5 is 15. 3 plus 5 is 8. So we're going to put the 3 and 5 into the parentheses. And they're both positive, so we write plus 3 plus 5. This is now the factored form. The factored form of x squared plus 8x plus 15 is x plus 3x plus 5. You're done. It is factored. If you want to check it, you can go ahead and FOIL and see if you get what you started with. I won't do this for all problems, but I'll demonstrate it on this one. If you FOILed x plus 3, x plus 5, you should end up with what you started with. X times x is x squared. X times 5 is 5x. 3 times x is 3x. And 3 times 5 is 15. Combine your common terms of 5x and 3x, and you get x squared plus 8x plus 15. So this was simply a check step to make sure you did it correctly. And yes, when you FOIL this, you get what you started with. So this was our final factored form. It just shows that that was correct. Now there's some variations we're going to have to learn. But let's try another one like that. Factor x squared plus 7x plus 12. Well, we know again that we're going to have x and x, because when we do the f of FOIL, the only way we're going to get x squared is if we go x times x and get x squared. Look at the last number, 12. List all pairs integer pairs that can be multiplied to give us 12. Well, we have 1 and 12, 2 and 6, and 3 and 4. Do any of these pairs add up to the coefficient of the second term, which in this case is 7? Well, 1 plus 12 is 13, 2 plus 6 is 8, but 3 plus 4 is 7. So, yeah, right here, the 3 and the 4. So we put the 3, in this case again, they're both positive, and you are done. That is the factored form. And you could go back if you wanted to and check it by foiling as we did in the last example. This is the factored form of x squared plus 7x plus 12. Well, we're not always going to have all pluses. Sometimes we'll have minuses involved. When we look at something like this, we still want two numbers that when multiplied give us positive 12, but they have to add up to the middle coefficient of negative 7. Well, the thing to understand here is you can multiply a positive times a positive to get positive 12, or you can multiply a negative times a negative to get a positive 12. Well, the only way you're going to be able to add and get a negative number is if it's a negative times a negative. So if this is positive and the middle term is negative, we got to list pairs of negative numbers that multiply to give us positive 12 and when added give us negative 7. And these are the possibilities. Okay, all those when multiplied, any of these three will give us positive 12. We have to find which when added give us negative 7. This adds to negative 13. This adds to negative 8. And this adds to negative 7, which is what we were looking for. Now, you have to put negative 3 and negative 4 into the parentheses. Negative minus, same thing. So you would write x minus 3, x minus 4, and this is it. This is your factored form of what you started with, x squared minus 7x plus 12. And again, you could check it by foiling. When you foiled it, you would end up with this. Okay, we'll try another one where we have a positive for a last term and a negative or minus here. Again, we know it's going to be x and x because that's the only way we can get our x squared out when we FOIL. Okay, we got to think of all the numbers that could be multiplied to give us 14, but when added give us, when multiplied give us 48, and when added give us negative 14. So we have a few more possibilities here. We know they have to be two negatives because there's no way we can multiply two positives and add them to give us a negative. So again, possibilities. Any of these pairs, when multiplied, will give you positive 48. We have to find which, when added, would give us the negative 14. And I think we found it. So you put in negative 6 and negative 8, or minus 6 minus 8, and you've Got it. That is your factored form. Okay, a little bit more involved, but not too much, is when your third term is a negative. This is a little bit different as it's noted up here. You still have the same where you have to have x and x. However, the only way you can multiply and get a negative is if you have one positive and one negative number. So we're going to list all pairs of numbers, integers that can be multiplied to give us negative. Again, we got to have one positive and one negative. And then say, do any of these pairs add up to the middle of positive 3, the middle coefficient? Well, it could be negative 1 and positive 10, or 1 and negative 10. It could be negative 2 and 5, or 2 and negative 5. Any of these, if multiplied, would give you negative 10. If we add them, negative 1 plus 10 is 9. And negative 2 plus 5 is positive 3. We can stop right there. We found it. So, minus 2 and positive 5, or negative 2 and 5, however you want to say it. Put those in, and that is your factored form. And again, you could do your FOIL and check it out, and you would see that, yes, when we FOIL this, we finish with this. Okay, here's one to try. Well, we need two numbers when multiplied give us negative 12. Again, you have to have one positive and one negative, and when added would give us negative 4. Well, all the possibilities. Those are all the factors that when multiplied will give us negative 12. So we just have to find the ones that when we add the two together give us the negative 4. And I think we can stop right there. So you simply put in the 2, and I don't care whether you call it negative or minus 4. Excuse me, minus 6. And that is the factored form. Again, you could test it by foiling. So what we see is when we have a minus or negative here, we have twice as many possible factors to try. So it can be just slightly more time consuming. Now, a little refresher here. If going back to FOIL, which you understand to be first, outside, inside, and last, if you multiply your first, x times x is x squared, your outside is plus 3x, your inside would be minus 3x, and your last negative 3 times positive 3 would be a minus 9. What happens is 3x and minus 3x cancel, and you're simply left with x squared minus 9. If we FOILed this, notice like the last problem, both are the same except we have one negative and one positive. So if we did the first, we'd have x squared, then minus 10x plus 10x minus 100. And again, these two terms would cancel, and you would end up with x squared minus 100. You can go ahead and try this example, and you're probably seeing a pattern developing here where if this is identical except with a plus and a minus, your outside and inside are always going to cancel. So you're probably to the point where you can look at this and say, yeah, I think that's going to be m squared minus 4. You can give it a try and see if that's what you get. In all these cases, the middle term canceled. So this leads us to the reverse of that, which is factoring difference of squares. It says if you can get a whole square root of each term and they are separated by a minus sign, it must be a minus. You cannot have a plus there. Then you can factor by difference of squares. So the square root of m squared is m. The square root of 9 is 3. So we'll set up our two sets of parentheses. Take the square root of m squared, which is m. Place that m and m. The square root of 9 is 3. So we write in a 3 and a 3. And you have to have 1 plus and 1 minus. And if you FOIL that, as we saw back in the other problems, your outside and inside would cancel, and you'd simply have your m squared minus 9. So the factored form of this is this. After you do a few of these, they actually become the easier problems to do. In this case, the square root of x squared is x. The square root of 25 is 5. So in here, we put in x. Here and here, we put in 5. And a plus and a minus. And yes, you could switch the order if you wanted to put minus and plus, as long as you have one of each of the signs. Now you should be getting to the point where you can just about look at this and tell me what the answer is. Give it some thought here. Well, if you said put in a D and a D, a 6 and a 6, and a plus and a minus, you're absolutely right. That's the factored form of D squared minus 36. That ends the factoring review. And we'll get on to a little bit more involved factoring in coming sections.